Recently, there's been a controversy about the truth about climate change, and whether or not it is all a hoax created by scientists or a real threat to society. There have been multiple people in both the media and politics that do not agree with the results of an immense amount of research that have been conducted about climate change, that any changes to Earth's weather patterns are naturally caused and not human-induced. When asked about the topic, said, "I do not believe in climate change, I believe in weather." The Intergovernmental Panel on Climate Change concluded that the scientific evidence for warming of the climate system is unequivocal. As well, 97% of the climate scientists all agree that these problems are human-induced and that something needs to be done. Due to this huge denial, I decided it was important to create this video to address the skeptics and present the data from the scientists in order to help convince those who are still on the fence of whether or not they believe in human-induced global warming. First, I'd like to present the evidence that we have that this change is occurring at alarming rates. Then, I would like to address the causes of this climate change. As well, I'd like to find some consequences that we can see in the future if we continue on the path that we are currently on today, and as well some possible solutions you can do yourself in order to address this problem. Okay, so what evidence do we have for climate change? So far, we know throughout the entire 4.6 billion year history of planet Earth, there has been many fluctuations in the weather. Within just the last 650,000 years, there have been 7 cycles of glacial advance and retreat, with the most recent ice age ending about 7,000 years ago. That time right there marks the beginning of our modern climate as human civilization. Although most of these changes have been caused by small variations in the Earth's orbit, that changes the amount of solar energy or heat that the planet receives. The problem is that this current warming trend that we have is significant because it's the first time that this fluctuation in the climate of Earth has been changed by human activity. There have been Earth-orbiting satellites and other technological advances that have enabled scientists to see the entire picture when it comes to climate change on a global scale that has been able to collect data for many years now. As well, ice cores have been used that have been drawn from Greenland, Antarctica, and tropical mountain glaciers that are reserved within information that show the Earth's response to changes in the climate. The evidence of climate change includes the rising of sea levels, a global temperature rise, the warming of oceans, the shrinking of ice sheets, the decline in Arctic sea ice, glacial retreat, ocean acidification, decreased snow cover, and increase in extreme weather events. These are all serious things that are occurring. So first, I'd like to look at the sea level rise. Sea level rise have rose about 8 inches in the last century, and in the last 2 decades, the rate at which the sea levels are rising have doubled. This puts many coastal cities on an alarming rate, with fear of frequent flooding, including the huge tourist attraction down in Miami, Florida, having problems where they call nuisance flooding, where there's no rain event occurring and there's just flooding throughout the streets. This is a problem as well in Venice, Italy, along the coast, and many other coastal cities that experience this problem with constant flooding that they have to address these issues. Another issue we have for global warming is global temperature rise. Since the late 19th century, the planet's average surface temperature has risen about 1.1 degrees Celsius or 2 degrees Fahrenheit. That has largely been driven by the increase in carbon dioxide and other human-made emissions that are emitted into the atmosphere. In the past 35 years, with 16 of the 17 warmest years occurring after 2001. With 2016 being the warmest year so far we've had on record, with second place coming with 2015. It'll be interesting to see where 2017 will fall on the spectrum. So far we know the months of January, March, and February were all the hottest months so far for each of those. Like I said, this is the first time that humans have caused this large-scale change in climate with the immense amount of carbon dioxide that we have put into our atmosphere every day. This graph here represents an atmospheric data of the amount of carbon dioxide that has been collected through the ice cores and other more recent direct measurements that we have taken. And it's nice to point out in this graph that prior to the Industrial Revolution, the atmospheric CO2 levels were never over 299 parts per million. Today we are at a level of 405.92 parts per million. This huge increase is vital because of the carbon dioxide's heat-trapping nature and their ability to affect the transfer of infrared energy through the atmosphere. There is no doubt the increase in carbon dioxide is a direct cause of the warming of Earth. Other evidence we have is the warming of oceans. The warming of the Earth is also affecting the oceans in a major way. Much of the increased heat and CO2 has been absorbed by the ocean, with the top 700 meters increased by 0.302 degrees Fahrenheit since 1969. The oceans take up 70% of the Earth's surface and inhabit many ecosystems, all of which are directly impacted by this increase in temperature. One of these acidification of the ocean. With an increase of dissolved CO2 in the water, they are able to mix together to form carbonic acid. This would decrease the pH of the water, greatly impacting the marine organisms, especially those that have a carbonate shell. The decrease in pH would impede their ability to formulate shells, and as the base of the marine food system would affect the rest of the ocean's organism. As well, other evidence that we have for climate change include a decrease in the amount of ice, showing with shrinking ice sheets. The Greenland and Antarctica ice sheets have decreased in mass. Data from NASA's Gravity Recovery and Climate Experiment show Greenland lost 150 to 250 cubic kilometers of ice per year between 2002 and 2006, while Antarctica lost about 152 cubic kilometers, which is about 36 cubic miles, of ice between 2002 and 2005. As well, we have declining Arctic sea ice, and both the extent and thickness of Arctic sea ice has declined rapidly over the last several decades. A decrease of 13.3% per decade has been shown to decrease in these ice amounts, which can be shown here in this picture are affecting the animals. As well, we have glaciers that are retreating almost everywhere around the world. This includes the Alps, the Himalayas, the Andes, the Rockies, Alaska, and Africa. We lose annually about 281 gigatons per year. As well, we have experienced a decrease in snow cover and more extreme weather events, both of which are more evidence that climate change is real. What causes this climate change? Most climate scientists agree the main cause of the current global warming trend is human expansion of the greenhouse effect. Warming that results in the atmosphere traps heat radiating from the Earth toward space. Gases that contribute to the greenhouse effect include water vapor, carbon dioxide, nitrous oxide, and methane. Water vapor is the most abundant greenhouse gas, but importantly, it acts as a feedback. Carbon dioxide is also a minor but very important component of the atmosphere. Carbon dioxide is released through natural processes such as respiration and volcano eruptions, and through human activities such as deforestation, land use changes, and burning of fossil fuels. Other greenhouse gases are methane, a hydrocarbon gas produced both through natural sources and human activities, including the decomposition of waste in landfills, agriculture, and especially rice cultivation, as well as ruminant digestion and manure management associated with domestic livestock. On a molecule-for-molecule basis, methane is a far more active greenhouse gas than carbon dioxide, but also is much less abundant in the atmosphere, so it has less of an effect on us than carbon dioxide does. As well, we have the nitrous oxide, which is another powerful greenhouse gas produced by soil cultivation practices, especially the use of commercial and organic fertilizers, fossil fuel combustion, nitric acid production, and biomass burning. As well, in the atmosphere, we have some chlorofluorocarbons, which are synthetic compounds entirely of industrial origin used in a number of applications. They are now largely regulated in production and released to the atmosphere by international agreement for their ability to contribute to the destruction of the ozone layer. So they have been stopped their emittance into the atmosphere.
Shutterstock music.
The thing with this greenhouse effect is we have these gases going up into the air, the methane, the carbon dioxide, the nitrous oxide, which is causing them to build up in the atmosphere. So when the sun, solar energy radiates down, it gets trapped into the atmosphere. Instead of bouncing back and going back into space, it stays on the earth, and that earth there is what's heating us up, and that's what's causing the issue, is that heat that is staying there from that solar energy. 80 to 90% of that energy as well is then absorbed by the oceans. On Earth, human activities are changing the natural greenhouse. Over the last century, of the burning of fossil fuels like coal and oil has increased the concentration of atmospheric carbon dioxide. This happens because the coal or oil burning process combines carbon with oxygen in the air to make CO2. To a lesser extent, the clearing of land for agriculture, industry, and other human activities have increased concentrations of greenhouse gases. The consequences of changing the natural atmospheric greenhouse are difficult to predict, but certain effects seem likely. This includes temperatures continuing to rise, frost season will lengthen. This has been increasing since the 1980s, and an increase of a month or more in the frost season is expected, and this will affect ecosystems and our agriculture, which is where our food comes from. As well, we can expect changes in the precipitation patterns. Since 1900, the amount of precipitation in the U.S. has increased, with some areas having increases greater than the national average, while others have had decreases. It is projected in the areas with increased amounts of rain will increase even more heavy precipitations, while others will experience more drought. This will also cause an increase in hurricanes that are stronger and more intense, and North Atlantic hurricanes have increased in the amount of Category 4 and 5 hurricanes since the early 1980s, which are the more severe hurricanes. As well, we can expect sea levels to continue to rise. According to NASA, by 2100, we expect a sea level rise of 1 to 4 feet. Already through global warming, we have experienced a rise of about 8 inches since 1880, when these records were first started to be kept track of. As well, we can expect the Arctic to become ice-free. So it is important for each person to individually educate themselves and make a decision on whether or not they trust the scientists on whether climate change is real or not, and from there it's up to them to make their choices in order to have a smaller carbon footprint and to help with this bigger problem as a whole. Thank you for listening to this video. I hope you learned something about climate change, and thank you.
Shutterstock music.